Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellyn, Illinois. And this video today is going to look at dynamic casting and as a solution to a problem. And then we're also going to look at the same problem and try to figure it out using the visitor-ish design pattern, using what we call double dispatch in order to solve the same problem. We're going to use a C++ example. We're going to use a video game example, but we're not going to do anything. We're not going to show anything visually or anything like that. It's just going to be a very simple C++ demonstration. I already predict this is going to be my most watched video of all times because, my goodness, who wouldn't want to know about dynamic casting and double dispatching? So let's go right to it. And so our example problem. In video games, you have objects, obviously, in your video game. And they're playing. I'm thinking of a Pong example. So I have a ball, I have a wall, I have paddles, and in more complicated things, of course, I have more objects to think of. But when two of them collide, and we're not going to handle, the math behind how do we know they've collided. We just say, okay, they've collided. Let's handle that. But how would we know what objects are what? So we know we have a collision between object A and object B, but at the time that we figure this out, all we know is that object A is of type object and object B is of type object. So how can we work it down so that we can figure out that object A is a ball and object B is a wall? How can we do that? That's what this whole video is all about. And so generally in a video game engine, or at least my video game engine in my other videos, that we generally maintain a vector of base class pointers, which hold all sorts of derived class objects. But again, how can we figure out what's what? And so you can see this example here. Like this is like a game of 20 questions if you only have like 10 animals to choose from. If you go to a zoo that only has 10 animals or whatnot, does it have feathers? Yes or no, yes or no. And eventually you figure out your answer of what kind of animal you're looking at. And it's similar in programming, but it kind of, you take away these kind of questions and all you can truly ask are, hey, are you a chicken? Hey, are you an owl? Hey, are you a turkey? And so forth and so on. You really can't go to the same level. That's where this analogy breaks down. But I just wanted to show you that it's the same kind of basic question that we're going to be asking. Are you a this? Are you a that? Okay, for our first solution that we're going to try today, we set up a virtual function. It could be pure, it could be not. I'm using a non-pure virtual function just so I have a base behavior of doing nothing, or in this case just printing something to the screen just to show how it works. And then you override this if you need to in every one of the derived classes. If you're happy with doing nothing on a collision, then just don't add anything to the derived class. But if you need to handle the collision in some way, shape, or form, then you're going to go ahead and override the behavior and then go and do stuff. And so when you do this virtual function idea, we enable what is called single dispatch, meaning of the two objects, object A and object B, when you get into the virtual function, you have already figured out one of the two object types, because that's what virtual function and inheritance, polymorphism, all that stuff does, is it works its way down to find out what function can I actually use, where's the most overridden version of that function, and then which object am I in? So you know if you're in a ball, you know if you're in a wall or a paddle or skeleton or whatnot. And so that's where this solution ends. Single dispatch is where this ends. And then to finish up the job, instead of doing the double dispatch part, what solution 2 does, this one we just use dynamic casts over and over and over again until we're happy with what we found. And we can just go, are you a ball? Are you a wall? Are you a skeleton? The only problem is dynamic casts are very expensive. It's a costly operation because there's a lot going on in virtual pointer tables and all sorts of things with castings and all sorts of crazy stuff that we don't need to discuss. You can read this up and do more research on your own if you would like. And so, oh my goodness, a downcast can be performed with static cast and this and that, whatever. But the whole point of this is you work your way down, you know you're inside of a ball, then you go, hey, are you a wall? And you go, yeah, okay, and then let's handle that collision and figure out what to do with that. And so it says here you can avoid this dynamic casting with solution 2, which we'll describe in a second, by providing virtual functions in the base class. And then this double dispatch approach in the visitor pattern. Again, visitor-ish is what we're going to do because we're not doing the exact visitor pattern, because our problem is a little different than what the pure visitor pattern is designed for. And so we can, and now we can solve using solution 2 in a way that does not use dynamic casting. So in this case, the solution uses the visitor design pattern, tweaks it slightly. We'll show that in the example in the C++. And we can eliminate the need for all the dynamic casts at the cost of making the base class and all derived classes more complicated to do the work, do the same work. And so we're ready to move on. My example here is the Pong game, just so you can see here, just so you know where we're going with this. So here is our wall at the top. Just consider that a wall at the top, a wall at the bottom, wall objects. We have paddles, and we have a ball. And say we're just keeping it very simple. We're not maintaining left paddle, right paddle, top wall, bottom wall, anything crazy. We're just maintaining 3 object types. And say, well, what kind of collisions do we need to take care of? You know, what kind, you know, what do we need to worry about? And in this case, the ball can collide with a wall, the ball can collide with a paddle, and then the paddle itself, as it goes up and down, can collide with the wall. And so those 3 collisions we need to handle. And that's pretty much the start of the video here. So let's get to the C++, let's get to the nitty-gritty, nerdy fun stuff. So in both examples, I'm using the same source.cpp file. I'm not changing this in any way, shape, or form. Let me just explain what's happening here, and then I'll show you the object-oriented hierarchy. So I have a ball that's derived from object, and wall is derived from object, and paddle is derived from object. And so I can set things up this way, where I can set up an object pointer, and I can have it, and I can set it up as a ball, and as a wall, and as a simple paddle. And so since there are 3 objects, there are 9 different ways that these things can collide, you know, depending on, you know, left and right orientation here. I can do ball, 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 wall, ball, paddle, and then wall, ball, wall, 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 paddle, and then paddle, ball, paddle, wall, paddle, paddle. So there's 9 different ways these things could collide in, you know, oriented left and right when it comes up to this. And so when I call this collide function right here, you can see when I get to here, all I know is that I have an object. I have the base class for A, I have the base class for B. That's all I know. And then I call the same function in reverse for both. And because if I'm making a game engine, there's no way I'm going to know which object is going to hold the code for, you know, the actual collision, you know, that's occurring. It could be A, it could be B, depending on how you've software engineered everything. And say I see a lot of students in my game development courses, when it comes to collision events in GameMaker or other things, try to put code in both, you know, both objects. But there are many reasons not to do that. You should always put your collision code in one of the 2 objects, because when you get to that point, you have both objects in front of you. Why would I need to double up and do part of the work in one object and part of the work in the other? Why don't we just get it all out of the way in one place, and then we don't have to worry about any silly race conditions or anything that maybe an engine does behind the scenes without your knowledge. So with this said, before I even show you everything else, you go, oh my goodness, this is going to be boring as all heck, object, object. But nope, the answer is not anything close to that. You know, all of these 9 different things print out different things, in different ways, considering the rules we've talked about in the previous slides there. So let's take a look at what the code actually does over here. Okay, so this is my base class called object. It has a virtual destructor just in case for memory leaks. That's always a big plus, right? Is no memory leaks in my program. And so we discussed, here is my virtual function called onCollision. It takes in an object. And okay, so at this point it doesn't do anything fun because this is the base class. And it's, again, I could make this pure virtual if I want, but I didn't, just to show you that it can print, because I have a base behavior that essentially does nothing. It's not doing any actual work here, and because the onCollision event has not been overridden by any of my classes down below. So this is the base behavior for everything. Here's my wall class. It derives from object. And so the collision event comes for free, and as we're discussing, walls do collide with things, but I've put that code in other places. I put it in the paddle instead of the wall, again, because I picked one of the two objects to put the code in. And my general rule of thumb is that stationary objects, you put as few of the collisions as you can, and the objects that are moving around doing the work, they get more of the collision functions. They do more of the work, and that's where more of the code should sit. So anything that collides with a wall will get this nothing to do from the wall itself. But what about the paddle here? It overrides the collision because it needs separate behavior. It needs to handle collision with the wall. And so we start with an object here. When we come in, we go, okay, I know I have an object that I'm colliding with, and I know I am a paddle because it can only get here if it is a paddle object. And so I'm a paddle, but we don't know what you are, second guy. So what are you? And you go, are you a wall? That's what this dynamic cast is doing. And you go, yep, I'm a wall. And then we print out, oh, okay, cool. And then this is where we would do the work of whatever we would need to do to handle the collision between the paddle and the wall objects. And basically we have both objects. So if we keep the dynamic cast, we can do whatever we want. Any of the APIs of the paddle and the wall we have access to. We can do whatever we darn well please. But if it's not a wall, that's the only thing the paddle can collide with. The ball can collide with it, but of anything that I set up here, you go, nope, I don't need to do any of that work. The collision between the paddle and the ball is handled in the ball object down here. And you go, nope, if it's not a wall, I don't need to worry about it because, programmatically we'll handle it somewhere else. So here's the ball. It's a little more complicated, but again, it overrides the virtual function. Object comes in, you go, hey, are you a wall? You go, yep, okay, cool. We have a collision between the ball and a wall. And if that's not true, you go, hey, are you a paddle? And you go, yep, I'm a paddle. You go, okay, now we're dealing with a collision between a ball and a paddle. And if it's neither of those, you go, nope, okay. We don't have anything in this game about balls colliding with other balls, so we don't have to worry. And we just print out, okay, nothing to do. So with that understanding, let's go run this again and take a look at what comes up. Oh, maybe we should look over here too. Let me see if I can bring this down and make this a little smaller, just a little bit. Yeah, it kind of works, right? There we go. And then there is my output. And you go, for a ball and a ball, there's no collisions. And since we do get in here, we just nope, and we come out here, it does print out here. It prints out this code. Oh, let me move this over so we can see both at the same time here. Okay, so you can kind of see that's why it prints out derived, because each time the ball is colliding with the ball, it is getting in here, but it's not doing any work because there's no ball on for the other object. Okay, ball wall. So again, the wall doesn't do anything; it just prints out nothing to do base. But on the other side, when the ball collides with the wall, that's why it goes into here. The ball object collides with wall, and it goes to this, and everything else just falls in. You can go through and you can see this. Because it calls A to B and then B to A, that if I did this right, I will only have one, because I only put the asterisks in the places where I would actually do the work of figuring out how to handle the collisions. So you could see here that in some cases I have nothing. That's good if that's what you want. And in other cases I have exactly one resolution. I don't have two. Notice nothing in here is showing two asterisks inside of any of the sections here. So it's perfectly fine to have 0, but you better not have, and it's perfectly fine to have 1, but according to just the way you should work these kind of collisions out, these kind of things out, you should never have more than 1, and that's pretty much everything there is to do for solution 1. And all it is for every object type that I want to derive from. For future, I just derive from public object, and if I want to handle a collision, I just supply this function, supply the if statements and the casts, and then get in wherever I am, I can figure out what's going on, and I can handle the resolution there. Okay, so now I moved on to part 2, the visitor-ish/double dispatch pattern, and now you can see, I would say the first solution was easy, quote unquote, to do. There's nothing really to think about, because I kind of quickly described how you would derive from this and figure out what to do pushing this thing forward if you had more objects to add to your game or to your engine or whatnot. But now on this end, again, notice that the code is exactly the same. I have not changed anything. And I get the exact results, the same results. Maybe they might be reversed here, but they get me to the same places. Well, there's 0 or 1 asterisks in each of the sections. And since paddles don't collide with paddles, there's nothing to do. Balls don't collide with balls. Walls don't collide with walls. There's nothing to do on those ends. But everything else, there's a collision that occurs between the ball and the wall, or the wall and the ball, and it's handled in one of the two virtual functions. So in that way, it's exactly the same. But now let's talk out exactly what's going on in the actual code over here. Let me make this a little bigger. Okay, so now it gets a little more complicated, and I didn't want to break this up into multiple files, so that's why everything is in one file. I would never do this if I was doing this, if I was setting this up professionally. I would break everything up into multiple files, 6, 7, 10 files, whatever I need. But now you can see there's a huge difference here. Actually, the only difference here is instead of doing on collision before, I'm using collide here, because now I have to call a virtual function to call a second virtual function, because we're single dispatching twice, and in the process of single dispatching 2 times, we're essentially doing double dispatch, and we can figure out the types of both A and B. Okay, so what does that all mean, Brad? So I'm saying I'm forward declaring all of my derived types, so I don't get any compiler errors or linker errors or anything at any point. I still have object with its virtual destructor, but now I have a virtual function called collide, and I'm making it pure virtual in this case so that I don't make the mistake of accidentally defining it here, because I have to define it in every one of the base classes because of the way that the dispatching works in C++ at the very least. If you'd be like, why? It's the same code in every derived class. It's exactly copy paste. Even wall has it. Copy paste, copy paste, copy paste. I don't know if the wall absolutely needs it, but I'm just keeping it. Yeah, it does need it because it's pure virtual, even if it doesn't do anything on the back end of this. But again, the reason why it's pure virtual up here and I'm defining this is when I call the function, it will do the dispatch, because it always does the dispatch from the base class and not from the derived class, or at least the class that it is. And so it's a confusing little thing. But when I call the collide function from over here, this guy, A arrow collide B, it knows to go into the ball object. And so now I'm in here, I know I'm in the ball, and now I can say, okay, I know I'm a ball, and I can pass myself along to the other class. Okay, so coming back here, so this is pure virtual, and so this function calls the second function, and this is where things get even more tricky, is that, and I have to know what I'm doing here, and I have to maintain this manually. There's no way to do this automatically. For every collision event that's ever going to occur in my game engine, I need this. I just need a virtual void function that's called onCollision that handles that specific type. Ball pointer, wall pointer, paddle pointer. And then I'm just, in this case, I'm just doing a print just to show, but you really want to have no behavior as the basis, just as before, where a lot of times you're having collisions between objects, but you don't want to resolve that collision there. And you don't want to have to define that. I do not want to have to go in here if I have 6,000 different objects in my game and, I need to set up a new object type and then have to write out 6,000 empty functions, virtual functions. That would be ridiculous. I only want to fill out the functions for the objects that are collided with this object that matter. And so in this case, pure virtual on the collide, and then this function calls the on collision here. And so class object goes, okay, I know, and say, but now another thing to notice here is when A calls B, A is, whatever is always to the left of the arrow is what is getting dispatched. So when I get into this function, whatever A is what I am. In this case, let's just say it's a ball. So I know that I'm a ball, and that's where the this comes in. And now to do the double dispatch, I call this on collision in reverse. It's B arrow A. And because of that, whatever's on this side is what gets dispatched. And again, I know what I am. I'm a ball. and that's what's going to go here, and then it's going to say, oh, okay, other object, I don't know what type you are right now, but at runtime we will figure it out, and it will call the correct ball function or collision function and do what it needs to do. And so it comes down to it, getting rid of this collide function, forgetting about it again. Now all I have to do is define 3 virtual functions for the 3 collisions that occur. The ball collides with the wall, handle that. The ball collides with the paddle, handle that. And again, I could I could reverse this, but I don't want to. Again, I want to handle every collision in one place and one place only. And so now I've done that, and now the ball specifically collides with the wall. I don't have to do any dynamic casting. I'm here. I can do whatever I want now, and I'm in the ball, so I can do whatever I want to the ball, and I can access the public API of the wall object or the paddle object or whatever's going on. And so what to do to push this forward if I needed a new class is I would class whatever, public object, I define this, and then whatever collisions I want to take in, I take them in and I override them. And if I don't want to, and for the ones I don't want, I leave them alone, because this virtual function here will be the default behavior, the nothing that happens between those 2 objects when I call the function. So again, it gets tricky because you're going to have, for a complicated game, you're going to have hundreds and hundreds and hundreds of collision functions here that are all virtual and they're all empty for every specific type. And so every time you're going to add one, you essentially have to go back in this case, this to me, this is part of the engine, not of the framework. This isn't part of your game. And so another problem with this is you're not decoupling your framework or your engine from your game, because you have to go in and manually do this every time you're adding a new collision in your game or a new object that's collidable in your game. Okay, so again, this is more powerful and it speeds things up, but there's more to remember and obviously more to do. And this took me a little while to just kind of think out, because this is not the pure visitor pattern that we want, but it gets the job done. I wish there was a way to eliminate this. I really do, because it would be nice to not have to worry about that, because why would you want to worry about that? But there is no way in C++ that I'm aware of to easily do that. Okay, so that handles both ways to cover something like a collision event that you would do in a video game. Whichever way you go is perfectly fine. There you go. We talked about that dynamic casts are slow, but how many objects does object A normally collide with? 2, 3? Is it that big of a deal? And is it like, is your development time more important than the time it takes to write out all this extra code? Or one way or the other, or do you even, until today, maybe you didn't even know that this was a way you could solve this kind of problem. When I first started, I'm like, how can I figure out what this type is? And then everyone's like, just use dynamic cast. And I go, well, there's got to be a better way. And this is exactly the way to go about doing it. Visitor-ish. I'm trademarking that one. Okay, so as always, if you have any questions or comments, please do so below, or get a hold of me at swardb@cod.edu, and I will get back to you as soon as I can. So as always, thanks for sticking it out with me. Have a great day, and I'll see you next time.